Hey there guys, this is episode 2 of Integral of the Day, and today we're going to solve this integral. And don't be fooled, it looks pretty simple, it's just a polynomial over another polynomial, but like I said last episode, do not be deceived by simple integrals because the solution can be very, very tricky, right? So, and by the way, I changed my camera to manual focus. It took me a while to focus on this board. And I hope the lighting would improve, so if it does, you guys can let me know. And also, I'm filming this entire series on my Canon EOS 77D, and I love the camera. It's awesome. And this is my first try at using it for videography, so hopefully it goes well, right? Anyways, getting back to this, so just a notice is it's that throughout the solve, we'll have techniques like u-substitution and partial fraction decomposition. So if you guys don't already know that, it's okay, because I'm going to go through it myself. Whoops. Right, so let's get started. Okay, so we notice that the denominator is x cubed minus 1, right? So we can split that into two factors as so. So let's rewrite this integral as x squared plus 3x minus 1 over x minus 1, or if you guys don't know, you can write a cubed minus b cubed as a minus b into a squared plus ab plus b squared. So that's a good thing to keep in mind for a long time. So it's a minus b into a squared, so plus ab, so it's x plus 1 squared, which is 1, dx. So we've basically written the same integral in a different form, and this form allows us to apply partial fraction decomp, right? So this expression here, x squared plus 3x minus 1 over x minus 1, x squared plus x plus 1, can be written as, some constant a divided by x plus 1, x minus 1, plus some linear expression bx plus c divided by the quadratic factor x squared plus x plus 1. And notice that bx plus c is linear and a is a constant. That's because the factor over here is quadratic and the factor over here is linear, right? So now what we're going to do is we're going to multiply both sides with this denominator so that it gets canceled out on this side. So when you multiply both sides, this is what we end up with. We get x squared plus 3x minus 1. So the denominator gets canceled, right? And then plus the x minus 1 gets canceled, so you get a times x squared plus x plus 1, and then plus bx plus c times the quadratic factor gets canceled, so into x minus 1. Right, so this is what we've ended up with so far. So now what we can do is we can expand the terms and then, match the corresponding ones and find the values. So this equals ax squared plus ax plus a plus bx squared minus bx plus cx minus c. Right, so let's regroup and find the coefficients of x squared, x, and the constant. So let me just rewrite this part, the left-hand side over here. So we can take x squared common, and then we get a plus b in brackets, and then take x common, and you get a minus b in brackets, a minus b plus c, sorry. And then the constant that you have left is a minus c. Right, so you notice that the coefficient of x squared here is 1, and the coefficient of x squared over here is a plus b. So we can basically equate both of those and form a linear system for all three coefficients. So we end up with a linear system, which is a plus b equals 1, right over here. And then this, a minus b plus c equals 3. And then finally, a minus c equals negative 1. So I'm not going to directly use elimination. I'm going to first substitute and then eliminate. So let's take this equation, right? A minus c equals negative 1. So we can rewrite this as c equals a plus 1, right? It's the same thing. So now let's plug this value of c into the second equation. So we end up with a minus b plus a plus 1 over 3, right? So that's the same as 2a minus b equals 2. So now we can take this equation and this equation and then eliminate. It's pretty simple. So we can just subtract the second equation from the first. The b's get canceled out. So we finally end up with 3a equals 3. So a equals 1. Let me just use my red marker for this so it's clear. A equals 1, then plug a equals 1 over here, so you end up with b equals 0. And then finally, you can just plug a equals 1 over here, and you end up with c equals 2. So now we got our three terms that we need to partial fraction decomp this expression over here, right? So let's rewrite that in terms of this. So let's rewrite the entire integral, okay? So we end up with the integral of a is 1, so 1 by x minus 1 dx, right? And then plus, we can split the integral, right? Because there's a plus sign there. So plus the integral of bx, so since b is 0, that entire term becomes 0. So 0 plus 2, so 2 divided by the quadratic factor, so x squared plus x plus 1 dx. So now we finally ended up with two integrals that we solve individually and then end up with the final solution. So I'm going to erase this board now.
A few moments later.
Okay guys, so we're back, and I just rewrote the same integral, which is down here. I wrote it back up there. So now all we have to do is solve both these integrals separately, all right? So the first one is quite straightforward. So let's just do it right here. So you can substitute x plus 1 as u. So you end up, so you get u equals x plus 1. And therefore, d of u du equals, just derivative of x is just 1 and the derivative of constant is 0. So du equals dx, right? So you can plug that in, and then you get the derivative of u over 1 over u du, which, as you know, is just ln of u. And then you can plug in u, and you get the integral as x ln of x minus 1. And you're putting the modulus sign there because you don't want the value of x minus 1 to be negative. And if it is negative, it'll become positive, all right? Because if you, for any ln or logarithmic function, you cannot have a negative number in that part. Okay, so we've got the first one covered. So this is number 1, right? And now we have to do this one, right? This one is much harder and takes a lot of time. And by the way, if you've noticed that the 2 is out, that's because it's a constant. You can bring it out of the integral sign. Okay, so it looks pretty difficult, right? But there is one thing you can do. So what comes to mind first is, why not complete the square for the denominator, right? So I'm going to write it like this. So 1 by, so you could write that as x squared plus x plus 1 over 4. And that could be factorized into x plus 1 over 2 whole squared, right? So you get x squared plus x plus 1 over 4 plus 3 over 4 because there's a plus 1 there. So let's just write that down here. So x squared plus x plus 1 over 4 plus 3 over 4, right? It's the same thing, just written in a different way. And now we can factorize the first three terms. So we get 1 over x plus 1 over 2 whole squared plus 3 over 4, right? So now if you've noticed something, this looks just like the derivative of the inverse tangent function, right? Tan inverse of x, the derivative is 1 over 1 plus x squared. But the thing is, we don't have it in the form of 1 plus x squared, because in the place of x squared, we have x plus 1 over 2. In the place of 1, we have 3 over 4. So let's take 3 over 4 common, okay? So I'm just going to get back the integral sign here. So we get 2 times integral of 1 over 3 over 4 times this entire thing divided by 3 over 4. So you get, let's see, just put this like this. x plus 1 over 2 whole squared divided by 3 over 4, right? Because when you multiply it, it just becomes 1 and you get this, and then plus 1, right? So that sort of looks more like the form we were expecting, but we're quite not there yet, right? So we don't want this 3 over 4 in the front, so let's just bring this back here. Let's just bring it to the next line. So let's just multiply the top and the bottom by 4 over 3, all right? So then that means that this gets canceled and the 4 over 3 comes out. So we can write this as 8 over 3 times the integral of 1 over 4 over 3. I just brought this bottom one on top. So 4 over 3 times x plus half whole squared plus 1. So you notice that 3 over 4 is cancelled, and now we don't have a constant in front. And this just, we just got the reciprocal of this and multiplied with the reciprocal. All right, so this sort of looks like the form we're expecting, but we're again quite not there yet. So let's get this 4 over 3 inside the bracket, all right? So this can be written as 8 over 3. That's always going to be there, all right? Into 1 over, so if 4 over 3 was in the bracket, we basically have to take the square root and put it inside. So the square root of 4 over 3 is 2 over root 3, right? So let's just write that here. So times 2 over root 3 times x plus 1 over 2 whole squared plus 1. Right? So we'll just rewrite this. Let's just distribute. So times 1 over, take 2 common here, so you get 2x plus 1, and then 2 is cancelled, so you get 2x plus 1, 2x plus 1 over root 3 whole squared plus 1. Okay, so we've ended up we're almost at the end, and as you can see, we've almost gotten the form of 1 over x squared plus 1. And instead of x squared, we have an expression. So now we can use u-substitution, right? It makes it much easier. So let's substitute this as u. So u equals 2x plus 1 over root 3. So that means that du equals, we can separate both of these. So this 1 over root 3 is just a constant, and then the derivative of 2x plus 2x over root 3 is just 2 over root 3. Right, so du equals 2 over root 3 times dx. Right? So that implies that, dx equals du root 3 over 2. So now let's plug that in. Whoops, I forgot that dx is everywhere. So now let's plug that in for dx. So let's bring that to the next step. So we get 8 over 3 times 1 over u squared plus 1 into du times root 3 over 2. So this is a constant, so we can bring this out. So we just end up with, you can just cancel out the terms yourself. So you get 4 over root 3, because 2 cancels 8 and root 3 cancels 3. And then 4 over root 3, derivative, I can't say that word, du. So now we already know the integral. So this is just 4 over root 3 times tan inverse of u, right? Fairly simple. And of course, don't forget to plug in for u again. So this is just 4 over 3 times tan inverse of, as we see over here, u is 2x plus 1 over 3. So 2x plus 1 over 3, right? So we've got our first term up here, and we've got our second term down here. So now we just got to put them together. So the final solution is ln of x minus 1 plus 4 over root 3 into tan inverse of 2x plus 1 over 3, and finally the constant of integration. Let's put that in a big red box because that was a hefty process and this is very rewarding. So yeah, this is our final solution. So as you can see, the integral, which is again just a polynomial divided by another polynomial, was not very easy to solve, right? Because this, you'd never expect a solution like this to come from that. So again, do not be deceived by how an integral appears, because they can always be very hard. So this is about it for today. I might get a different problem tomorrow or day after, whatever. And this time, it might not just be a plain integral because they kind of get too boring. So we'll have like an application problem, like, you know, I don't know, finding the volume of revolution, like washers, cylindrical shells, and stuff like that. So yeah, this is it for today.